Good afternoon, students. Myself, architect Dinesh Bhagat, senior lecturer in architecture at Government Polytechnic College for Girls, Ladwali Road, Jalandhar. My today's topic is design of fuel station. Fuel station means petrol pump. So we'll be discussing what exactly a petrol pump is and how do we design it, what are the major components, then technical details, and we'll try to analyze with one typical plan and the major components which are involved into design and into the technical details. So just to begin, we'll start basically the petrol pump or fuel station section with a typical plan. So what exactly are the components in it? First of all, what we have is the underground tanks and then a building and islands, and then the parking if at all it is required. The parking is there into a petrol pump if it's relatively bigger. Otherwise, the parking, not much of a parking is provided. Only we have arrows and inlet and outlet marks within the driveway. So, what is driveway? First of all, let's try to discuss what exactly are the components of a fuel station. The components will be like number one is driveway. Driveway is this overall part from where we drive our vehicles in and then we drive out. This is the hard surface where we are going to have everything. So entire petrol tanks, canopy and pipelines and everything is situated under the driveway. So in a way, like whatsoever is on the top, say 80% of the petrol pump is underground below the driveway, because below the driveway we are going to have our underground tanks, pipelines, then again the connections to the buildings, then connections, electrical connections and everything is below this driveway, which is comprising of a major part of the petrol pump. So we'll try to discuss each and every aspect. Number one is the driveway. Then we have islands. Islands are these parts where our machines are situated. Generally, we are having two islands, three islands, four islands, depending upon the place and the location. So depending upon the place and the location, these islands can be more or less. Like if it's on a highway, or a national highway, you will be having more islands. Where the traffic count is more, you will be having more islands, because as far as the traffic count goes, you will have more of diesel vehicles, bigger vehicles. So we require more turning radius and more areas. So we'll be requiring islands onto the front side where bigger vehicles are going to operate, and the islands at the back may be smaller vehicles, maybe like cars and two-wheelers. So our front islands are going to have our bigger vehicles such as trucks, buses and all, even bigger trucks like 9 ton, 16 ton and 21 tonner, that kind of vehicles are going to be accommodated only onto the front islands. So apart from this driveway, then you have islands, then we have underground storage tanks. So underground storage tanks, these are located under the driveway. So there are two options of housing underground water storage, underground fuel storage tanks. Underground fuel storage tanks, number one, it's in BM pit. What do you call as brick masonry pit, or the other way around, it's in an earth pit. BM pit means it entire brick masonry is constructed along the walls, and then a underground tank is lowered down into that pit, and within that pit you have sand all around, and then we are going to have an RCC slab on the top, and plus a cutout for having that hole from where you will be having that filling and decantation point and that kind of things. So if we are having the tanks in BM pit and brick masonry pits and a RCC slab on the top, entire vehicles can ply around or move around on the driveway. So most of the cases in urban outlets or in highway outlets where the space is lesser, we are going to have the tanks in BM pit, in brick masonry pit and an RCC slab over the top, and eventually the vehicles move over these underground tanks. But in case the outlet is situated into a remote area or where the consumption of oil, petrol or diesel is little lesser, it's into the rural areas where the amenities are less. In that case, or in other words, you can say where the budget, the company is not permitting, the owner is having a lesser budget, we are going to have these underground tanks in earth pit. So when we are going to have these tanks in earth pit, the vehicles cannot move on the top. So it will be placed at a corner, maybe somewhere over here if it's a typical plan. So these are plan maybe placed over here, and our vehicles will not be moving onto those tanks. So beyond those tanks, we are going to have a curb wall or a curbing, so which will be defining our traffic movement or our inlet or outlet traffic. So these underground tanks are a major component where our entire fuel is housed. So ultra care has to be taken in putting up these underground tanks. Uh, like we have the capacity of these underground tanks is varying from 9 kl to 12 kl to 16 kl to 22 kl, and even it can be as high as 40 kl. 9 kl means like we are housing around 9,000 liters of petrol or diesel. The second one is 16 kl, it's like 16,000 liters of petrol or diesel. And then apart from this, we have 22,000 liters, and then 40,000 liters, that's 40 kl. So we decide the tanks as per traffic and as per the usage of the fuel in that particular highway or in that particular city outlet. Supposing if we are having an outlet on a highway, in that case our the traffic count and our consumption of diesel will be much more as compared to petrol. While in a city outlet, it's like 50-50 kind of a case, because even the smaller vehicles are getting diesel engines these days. So depending upon our consumption, we are going to put our tanks. It will be either 9 kl, 16 kl, 22 kl or 40 kl. So the combination of tanks like 16 kl, for instance in this particular drawing we are showing 16 kl 16 kl tanks, like 16,000 liters of petrol or diesel in one tank, and we are having 4 number of underground tanks. So these like the petrol is different, then again the diesel is different. Apart from the petrol, there are other some premium brands, like in diesel these companies are selling turbo, and in petrol they are selling like power, which are a little bit costlier than the original ones. So separate tanks are given for these kind of things, and we need to have proper provision for the pipelines, and again everything is computerized and automation is done. Like is a person sitting into this sitting in the office can have entire control on how much the fuel is there into a particular tank and how much it has been sold in one particular hour, and from there on it is connected to the main server in the zonal or head office, and again it is one can come to know how much sale has been done in particular time, in particular days, in particular month. So it is fully automated kind of a thing in which we are going to have petrol tanks and diesel tanks. So apart from these, we'll try to discuss uh, what exactly the other items are. The other part is ingress and egress. The ingress and egress is like the entry and the exit part. So the entry and the exit part, we apart from this entry and the exit part, we are going to have a declination lane. That is, if an outlet is on a highway, we are going to have another 70 meters lane onto the left and 100 meters lane onto the right. For that, for so that the traffic on the highway moves in effectively. So these are the norms as per your national highway, but these norms are not followed into the city outlets, where this ingress and egress depends, like it starts from 9 meters to 16 meters. On highway it's around about 12 meters to 40 meters, and city it's around 9 meters to 12 meters. So depending upon the location of the outlet, this ingress may vary from 9 to 16, or maybe if it's a smaller outlet in a city. Smaller outlets in the city are like those which are around 18 meters into 20 meters. So these kind of outlets are having an ingress of about 6 meters. So officially these outlets are called two-wheeler outlets, and officially the larger vehicles or trucks or cars are not allowed as per their license. So maybe practically these guys are housing these kind of things, but again if it's the minimum size in of a petrol pump for a full-fledged outlet, it's like 30 meters by 30 meters. It can be even 30 by 35 or maybe 40 by 45, that kind of a thing. So in that case, the ingress and egress, it's around about 9 to 12 or 12 to 14. The egress is little more than the ingress, because the people tend to move bit faster onto the egress side. So apart from the egress, when we are ingress and egress, what we call as in and out of a petrol pump, we are going to have a green belt at the entrance. This green belt, we call it as a D. So this is a buffer zone where even landscaping is there, and entire lighting and the main signage and display of the rates is all onto this green belt. So this is into our buffer or D area. So this green belt houses the entire electrical poles and everything, and apart from this, it even houses our rainwater disposal. The rainwater disposal of the entire outlet comes into this ingress and egress area, where we are going to have a drain. We are going to have a drain. So this is the kind of a drain. If it's a rural outlet, this drain is little smaller. If it's a highway outlet, this drain is like 1 meter. The section of this drain is 1 meter by 1 meter. If it's a rural or a smaller outlet or a city outlet, the section of this drain may vary from like 1 feet 6 inches to 1 feet 6 inches to 2 feet by 2 feet. So onto this drain, we are having grating, and entire water from this very area is trapped into this drain. Even we guys are going to have back slope into this very area. Like back slope is the slope from outer area, from the PWD area, and slope from our main outlet. The entire water, uh, the rainwater or the main water, this is collected into this very drain, and again with the back slope of the highway, water is again collected into these drains, and it is then sent back into our rainwater disposal well, which is located into this landscape area. So the what like the slope followed over here is 1 to 2% of the total depth. Like if the depth of the outlet is around about 45 meters, in that case our 1 meter, considering the 1 meter slope, it will be 40 centimeters. 40 centimeters of slope from this front corner to the back corner, and entire water will be collected into this drain, and then a back slope from the highway, and this water will be collected into the drains, and it will be put down into rainwater disposal well, which will be housed somewhere here into the green area. So this drain is mandatory as per highway, as per our local norms, as per our even pollution control board norms. So this drain is mandatory just to collect entire water and everything, which is again drained back into our rainwater disposal unit. Then the other thing, like we have discussed, is the buffer or the D area, where we are going to have signage and everything, that is all housed into this very area. Then is we have underground pipeline. We have underground pipeline from the tank to the islands, and thereby connecting it to the dispensers or our units. So a pipeline starts from our tanks and it goes to our dispensers. It may go like this and again like this, and from here to here. So it's again a section of around about 1 feet 6 inches by 1 feet 6 inches, or 450 into 450, where we are going to have pipeline. So pipeline in a petroleum outlet is a GI pipe. GI pipe. GI stands for galvanized iron. Galvanized iron pipeline, C class. There are 3 types of pipes, A, B and C. A, B and C pipes, this is a classification in our plumbing. So C is the highest rated, like the best and the thickest. Those kind of pipes are used into for carrying these fuel from these tanks to our dispensers or machines. So because it has got, in other words, we can't use GI pipes. GI is the galvanized iron pipe. It is CI, cast iron pipe, because GI pipe is having more conductivity, and in that case we can land into more troubles, and there are chances of fire. So being taking no chances of a fire, and as per specifications we are going to have CI pipes, C class pipelines, CI pipelines. Again it varies from like 40 mm to 50 mm. The pipeline thickness may vary from 40 mm to 50 mm. So these are a bit of technical details. So these underground pipelines, they are all connected to our machines, and thereby these machines or dispensers, they are having like 1, 2 or 3, and at times 4, 5, 6, 3 nozzles on one side, 3 other nozzles on to the other side. Our machine is like modern machines are going to have 4 to 6 nozzles per machine. So that way, like 4 to 6 nozzles over here, 4 to 6 nozzles over here, 4, 4, 8, 12, 16, and like 20 nozzles are there. So having 20 nozzles for petrol or diesel, maybe it can be like 20 to 30 nozzles. So 20 to 30 nozzles means you are having at least 20 motors which are carrying petrol or diesel into that machine. So 20 motors, it's a hell of an electric load. So 20 motors for the machines. Then again we are going to have load for the building, then again for the lighting and many other things. So our this petrol outlet has to be, we have to be very careful in our electric jobs. So electric jobs have to be very careful. So entire underground electric job is carried under the driveway, and we are going to have small chambers which carry the entire wires. So these are thicker wires, like 3 core or 4 core wires, depending upon the machine and the specifications and the loads. So those kind of wires have to be there, and we are going to have underground wires in Hume pipe. Hume. What is a Hume pipe? Hume pipe is a it's like a concrete pipe running under the driveway and having chambers at various intervals, like at the corners, and I can show you it in few pics. Mm, these are the chambers. These are the chambers, and here these are the islands. So these are the columns, and here we are having a canopy on the top. This is a typical picture which shows islands, DUs. DUs are these dispensing machine, dispensing units or machines, and then again spreaders. Spreader is again this is an ornamental item where maybe some sort of lighting or some signage is being used to highlight the company's logos and their color scheme. So this may or may not be there on a particular company. Like this particular company is using these spreaders and the color schemes for these kind of things. So here we are going to have these kind of chambers. From here, these like these chambers. From here, entire wires are connected to these are machines, and from here these are connected to intern next, and from here this entire wire goes, everything goes back into our electrical room, which is housed somewhere into our building. That wires keep on going and going back at the electrical room, and electrical room we are going to have a panel and earthing, because our machines are going to be very expensive, and it's entirely in an fully automated electronic version. So we need to control our electrical equipments and everything, electrical and electronic equipments, in a very sufficient way, in a very efficient manner, so that all electrical loads can be managed properly and there is not much of tripping or fluctuation, because with much of tripping and fluctuations these machines can get damaged, which are like in the range of like start and modern machine starts at a range of around about 5 lakhs to 10 lakhs, depending upon the nozzles. If there are 2 nozzles, it might start around 5-6 lakhs, but like modern machines, these start at around 10 lakhs, 12 lakhs or 15 lakhs. So each nozzle is like 2-3 lakhs. Each nozzle costs around about 2-3 lakhs, and just to control these machines and effective supply, we need to have a very uninterrupted power supply. So to have an uninterrupted power supply, we need to have an electrical room and an electrical panel, and apart from that, every other equipment in this petrol pump is fully secured by means of earthing. We intend to have earthing for every island, every machine, every tank, and every light, and every building, and every room. Like lots of care has to be taken for the earthing, so that our equipment does not get damaged. So electrical and mechanical and civil, these are the major parts which are in a petrol pump which has to be taken care. Like these machines, if I tell you that this machine, if this is going to have 4-5 kind of nozzles at every outlet, and a normal highway outlet is having 3 islands and 4 on each, and 6, 4, 6, that's 24, like 24 machines are there, and 24 independent wires are running down to this electrical room. Apart from this, from the motor you are having display cables and again your electronic cables. Like each machine is going to have 24 into 3 or 4 cables. So 24 into 4 or 3 cables, 70, 80 cables are purely for the machines. 80 cables are there for the machine, and we need to have a bigger dia pipe and bigger dia everything, so that it like 80 number of our cables run down to our electrical room, and an electrical panel is there, and everything is controlled efficiently. Apart from these, like 70, 80 cables, we are having like at the night time we are going to have perfect like lighting, these lightings into our canopy area. So canopy area is going to have lightings around about 10 to 12 square meter, one light for 10 to 12 square meters. So if a canopy is around about 250 to 300 square meters, which a normally standard canopy is, say around 250 to 300 square meters, in that case we are going to have around about 24 to 30 lights in the canopy, and maybe maximum of we can connect, if we are going to connect these lights in series, we can connect 2 or 3, like 24 lights or 30 lights. We will be having another 15 number of cables, then 15 number of cables for these lights, and 24 number of cables for these machines. Then again we are going to have cables for these fascia. We have a lighting all around, maybe 2 cables all around, continuous around about 40 odd tube lights are being installed on 3 sides. So 40 to 45 tube lights. So like 6 to 8 cables for these fascia, then again independent cables for these kind of logos, then independent cables for these kind of spreaders. So like 15 cables for this, 3 for this, 18 and 6 for this, 24, and another 10 for the fascia and everything. It was another 35 to 40, and earlier we had counted around about 80 plus 40, 120, and maybe another around about 20, 15, 20 cables for the lighting and every other thing for the building and everything. In nutshell, we are going to have around about 150 cables running down to our electrical room. So it's a hell of a like this electrical room is going to have everything, around about 150 cables. We need to have separate circuits for the machines, for the DUs, for the buildings, for everything on the petrol pump. And in case we are housing a convenience store or complicated kind of a thing onto our petrol pump, we need to be very careful in that kind of a thing. So let's try to analyze those kind of things. Okay, the other parts are we have all seen driveway islands, underground tanks, ingress, egress, buffer, underground pipelines, then again a small curb. What is a curb? Let me show you. It's on to small pic where you can have see curb. This yellow kind of a thing, small partition at the end of the wall. These are the curb. It can be curb stone, it can be curb wall. Like certain companies are like this is like blue and black. Certain companies are having it like as per their color scheme. It's like red and blue depending upon their color schemes. So we have already discussed what exactly the drain or the catchment area. This is the drain where we have 1 to 2% slope over from this side, and again a back slope from the highway where the water is collected into this very drain again. And then we are having a canopy. Canopy is a prefabricated structure. This is like a rural outlet, and if we are going to have a highway outlet, in that case this kind of a structure which will be supported on columns. It's a prefabricated structure where we are going to have this is erected on columns, steel columns, and then again trusses are there, and it's a double roof kind of a thing. We have a ceiling and a roofing, and again